Good morning, everyone. Thank you for joining us today and welcome to today's webinar presentation. Today's topic is reality capture and simulation, real applications of digital twin for your facility. Our presenter for today is Dave Stone. He is the Director of Simulation at PMC. Please note that your microphones have been muted to prevent any background noise throughout the presentation. If you have any questions, please utilize the Q&A button at the bottom of your screen. We will be holding a live Q&A session at the end of this presentation where your questions will be answered. If you have any issues with sound or visual errors, also be sure to utilize the Q&A as well, and I'll do my best to help you as the presentation continues. This webinar is being recorded today, so if you miss anything, don't worry, and it'll be uploaded to our YouTube channel later if you want to review it. But let's get started. So before we get going with the presentation, I'd like to do a brief introduction into PMC. Dave, if you could go to the next slide. Since 1979, PMC has helped over 700 companies by completing more than 7,000 performance-enhancing initiatives worldwide. Our commitment to excellence has brought us to the point where we are the largest independent industrial engineering services firm in North America. PMC has worked with hundreds of businesses across all industries to improve their businesses' performance. And shown here at the bottom is just a few of our current and repeat customers. Today's session will be focused on reality capture and simulation, but here's a sampling of the other services that PMC offers. These include things such as laser scanning and drone photogrammetry, traditional industrial engineering services, simulation modeling and analysis, safety and quality, steel detailing and fabrication, and jig and fixture design. I'll leave this up a little bit so you guys can check it out. Now, I'd like to introduce Dave Stone to begin our presentation, Reality Capture and Simulation. Dave, take it away.
Good morning, everyone. My name is Dave Stone. I'm the Director of Simulation Services at Production Modeling Corporation. I'm a veteran of the auto industry, over 30 years in automotive. Our agenda today will be transforming manufacturing through data, the digital factory of the future. We're going to cover the basic 3D layout, advanced 3D layout, laser scanning, why we simulate, and a multi-agent system using simulation, and then a question and answer at the end. So basic 3D, very crude graphics, very flat drawings. Planning for yesterday, data collection could take months. 2D to 3D conversion was complex. Laser scanning was not a full-scale option. Simulations were more advanced, but often 2D. You can see a 3D model running over on your right side. Designing yesterday. Primitive virtual validation begins. Hardware is still a struggle. Laser scanning takes root in manufacturing. Sharing of information improves. Progressive companies begin asset libraries. Simulation advances and kinematic simulations begins to make major impacts in the industry. And as you can see at the picture at the right, a laser scan. Today, advanced 3D, as you can see in the pictures we have here, what is a photo and what is a scan, and what's the result of the simulation. Today's planning. 3D leaders are well-established 3D workflows. 3D allows for advanced studies to be done in hours versus days or weeks. Asset libraries allow for more advanced early planning. Assets go beyond geometry and include data. Today's designing. 3D factory design is still evolving. At the low end, there's still 2D disconnect, but in best in class, highly collaborative 3D. Barrier to entry of the 3D factory is much lower than ever. Assets allow the standardization in designs process and use the virtual reality for earlier, better validations. You can see the scrolling through on the right side. asset libraries. Here we have our asset libraries that we've built. As assets allow us for faster model build, layout development, and corporate standardization. Years ago, when PMC was working with asset library for General Motors General Assembly, it was drastically changed how the General Assemblies were designed and built. At first, we built the assets just to speed up our design development, which it did. Over the course of a few projects with General Motors, some of our program managers at GM started to notice that GAs were becoming more standardized just because the layouts consistently showed the object. They launched an initiative to fully standardize everything you could install for General Assembly. One basic example, standards for the control and monitor boxes for torque tools. There are 100 of these tools in a modern General Assembly. And historically, they've been just installed wherever someone felt like putting them. This causes a number of downstream issues, particularly for maintenance and install cost. We developed an adjustable stand that could hold 1 to 6 torque monitors and accommodated all the manufacturer equipment to speed up the layout design work. With a few changes, our assets, which is this library that we have, became the GM standard and are now in all GAs. This means that consistently for the maintenance team, the stands can be reused from program to program. Part of why this works is because the physical installation is a direct derivative of our layout design. If you standardize the design and the real world follows, this can save tens of thousands of dollars on initial installation and maintenance and make you run more efficient. So here we'll go back to the large objects. You can see these are CC90s, CC91, CC34s, dollies, dolly lifts, fork trucks. You can see the different taco stands that are down there, the tip tables that we have. So why do we do that? Well, today building, we have dramatic reduction in project total cost and overages. Most issues are resolved digitally before hitting the floor. Large reduction in engineering presence that's required on site. This mostly results with remote coordination meetings. Build to model workflows and offsite fabrication. As you can see, as we're scrolling through, you're seeing some of the scans, and then you're seeing the live photograph of what is going on in that same area. Today, operations may be siloed, which makes data flow extremely challenging. Production data is measured but not always shareable. Gaining acceptance, energy consumption and simulation, predictive maintenance, asset tracking and management, production dashboards across all company assets. So you can see a virtual assembly that's here in this. So what are we doing tomorrow? Data-rich factories. We're getting information from robots, delivery systems, and we're building dashboards. As you can see here on the pictures that we show you, some are virtual, some of them are photographs. How do we do it, you ask? Tomorrow's planning, single source data for multiple constituents, full life cycle implementations of operations data, feeding into planning data. Sustainability starting at the planning phase, not at the install phase. Emergence of cheaper, faster reality capture, increased automation and model development. As you can see here in this photograph, this is actually a model that was built using one of the softwares. Designing for tomorrow. We're going to be virtual commissioning. Validation becomes more mainstream and accessible. Great model access, data democratization. More access equals better designs. Reduction in duplicate data. Single source of truth. More factory data. Assets publicly available. Ability to integrate true product and tooling data into the factory floor design at scale. Embedded data will allow rapid calculations. So you can see here the data, the floor of an assembly plant. Very lean, very clean. How did it get to that point? Well, one of the things that we do at PMC is we offer a global reach for local service of laser scanning. We have engineering centers and scanning equipment that's both in the United States, Mexico, India. We cover Europe and China. We're the world's largest manufacturing scanning company. On average, we scan over 10 million square meters of factory space per year. Most of that has been automotive, but we have been branching into other companies. What is reality capture? What's laser scanning? As you can see here, we have a ferro scanner on a tripod, traditional method. There are two ways. What is reality capture? The process of digitizing the real world. Two primary ways are based on laser and photogrammetry. Color versus black and white. Color is captured with an integrated camera on the scanner. Capture of color data increases capture time by 150%. If you don't need it in color, don't use it. Color can provide visually stunning data. Color capture should be done when site is not active. As you can see the two photographs here, one is in color and one is in black and white. There's 4 phases to reality capture. Details of each phase will be based on the hardware and software used. There are dozens of possible outputs of the data. Outputs can be point data or model data. So we plan, we do on-site scanning, then we have to do registration, and then we have to do outputs. So you can see in the pictures here, scanning data, photogrammetry. Once we get on site, fixed scans take 5 to 15 minutes each. Expect every 4 to 5 scans to cover 1,000 square foot of the scope area. Best to scan when the site is inactive, but it's possible on active sites. Depending on the size of projects, targets may be needed, and that's what we have in the box here. And in some cases, permanent targets are required for multiple trip scanning. As you can see on the layout, the dots where we're scanning some of our targets. Registration, fixed scanning, scans an individual setup of scanning equipment. Point cloud is grouping of the scans together, which have been registered. Registration is the process of combining multiple scans into a single point cloud. So as you can see, we've done multiple scans and we've created the point cloud. On-site scanning can be done mobile or SLAM. Scan capture is continuous. Expect 10,000 square feet per capture per hour. Best to scan when the site is inactive, but it is possible when you're on active sites. Depending on the size of the project, survey points may be needed. Permanent targets are required for multiple target scanning. So as you can see here, the gentleman's wearing a NavIs. There's also a NavIs on a push cart and follows the path. And as you can see on the right here, we're going across that facility. You'll get done, you'll get your point cloud. Accuracy, you ask how accurate it is. Well, we follow the U.S. Institute of Building Documentation, which has 5 levels of accuracy. These levels are defined the accuracy spread of the data. For example, every measured point in LO20 data set should be no greater than plus or minus 50 millimeters off accurate. should be expected to be no closer than 15 millimeters. So you can see the different standards here. LA10 is 150 for upper, and lower is 50. LOA 20 is 50 to 15. LOA 30 is 15 to 5 millimeters. LOA 40 is 5 millimeters to 1 millimeter. LOA 50 is 1 millimeter to 0. Measured point clouds, you can see represented surface objects. You're seeing that the graph here on the side, what can happen. So how do we do it? What's the difference? So the Faro scanners are plus or minus 2 inches. Medium speed capture, its practical range is 50 feet. Most general purpose scanning projects can use this. Next, we have the NavIS and NavIS Mobile. It's plus or minus 0.5 inches. It's very fast. 50 feet is a practical range. When accuracy can be traded off for speed, this allows the site tech, and when the site allows for the tech. So if you don't have fast time, the time available, we can use that system. The next is a handheld Faro, plus or minus 2 inches. It's ultra fast, but only scans 20 feet. Used when speed is most important. Then we have the drones, which do plus or minus 1 inch. They're fast, long range site capture. The next one is a ultra fast capture speed, 5-inch practical range, simple sites, high volume. Accuracy is unknown at this point. Here's a 3D simulation. So when we built this model, might be your factory, it might be your competitor's factory. This is done in Technomatics plant simulation. You can see the cranes are moving, unloading and loading on the left-hand side with a fork truck bringing material. You have several robots that are unloading onto conveyor systems. Inside the area, you have people that are walking around. On the right side of the model, you can see more AGVs taking things in and out of the plant, moving them to different areas. So this is what 3D simulation will give you. Now, why do we simulate? What is it? Well, simulation is the art and science of creating a representation of your process system for the purpose of experimentation and evaluation. Why you should use simulation: prediction, enhanced safety and security, testing alternatives, what if analysis to optimize your process. It's a powerful communication tool, save time and cost in your designs. When you should simulate: when analytical approaches are not suitable. Stylistic process, too dynamic, highly complex. Real life experiments aren't an option because the system is fixed and locked, or the system does not yet exist. High risk, cost, and time needed. How to do simulations of pedestrians. We'll look at pedestrian dynamics software, plant sim software, AnyLogic software. Each pedestrian is represented individually. An interaction between pedestrians, traffic, and infrastructure and services. Now we'll look at the tool, pedestrian dynamics. It's a crowd simulation tool. So crowds are microscopic simulation, individual pedestrian characteristics capable of simulating large crowds, up to 1 million people. Multi-layer environment, rapid modeling, building of complex infrastructures through the import of your CAD data and BIM data. Multi-sequential processes, design, operation, and repurposing of that. Multiple outputs for analysis, density, throughput, wait times. There's a 2D and 3D visualization of interaction between pedestrians and infrastructure. Validated, verified, developed in close cooperation with academia. And it was validated and verified according to international guidelines. And they continue to invest in the research and development of the tool. So what do we get out from pedestrian dynamics as an example? So here's a 3D view, density maps, travel times, evacuation times, flow counter. So the red areas in the density maps, we're talking about the flow counter where you're getting high flow, and the density and LOS over time. So you can see the graph right here on the right showing you peaks as you're going, and then when you get all your people out, you're done. So here's an office evacuation. So people are going about their office, milling around, coming and going, doing things. They're coming into work in the morning, going to different cubicles, going to meetings, coming about, and an event happens. Now we have to evacuate. So as you can see, we're getting a bottleneck over here at the stairs. More people went there than it can handle. So it's taking you time. As you can see, the time at the top right-hand corner is still counting down the pedestrians. The left side of the office where they went down the escalator is empty. We're over 2 minutes to clear out the office now. And you ask, why does this matter? Well, if you're trying to eliminate a hazard, trying to get people out in time, you need to know how long does it take to clear out your office areas. 3 minutes and 20 seconds. And that'll be where I have any questions.
Yep, we did a few questions come in throughout the presentation, Dave. So we'll get started with those, but please, like I said before in the beginning, if you have any questions, utilize the Q&A button at the bottom of your screen to submit your questions, and we will have Dave answer those for you. So Dave, the first question we had come in, when it comes to evacuation analysis, are there specific challenges that you see when communicating to stakeholders and convincing them that the results of the simulation can be trusted?
So the answer is yes. The difficulties are people not being able to see. You have the evacuation routes laid out on a nice placard, but you don't really see the flow of people. And with our pedestrian dynamics tool that we're using here today, it shows that we can do a factory simulation, an office simulation, and you can see real time what happens. And then if you run the drill, and every large automotive manufacturing plant I've been in the springtime in the Midwest has always run a drill, and you evacuate the people and you see how long it takes and you do a head count. And if you generally see this same data, if you were to do this and find better rally points when you're completed, it'll save you time, and it may end up saving someone's life. Go ahead, Brian.
Yep, thank you, Dave. The next question we had, what kinds of data does the software support to build the models? You mentioned BIM and CAD for the infrastructure, but what about the rest?
So modeling, we can import a lot of different file types, step files. You can import just about anything. We do a lot of SolidWorks modeling. We can import those. Factory data, import of that data. So and each software has its own list, and you go through the picture. IGES is one of the ones that you can bring in. I think that's it.
All right, thank you, Dave. Another question we had, what are the benefits of including simulation into your digital twin model?
So one of the benefits that we recently worked with a company, they're going away from traditional uh, individual workstations and building a conveyor system that their general assembly will be a one part flow. Uh, and were wanting to show what happens in our factory. So we're scanning that factory. We're going to import the layout into the model and actually show the the employees of this company and the executives what the new factory of the future is going to look like. And we're also going to read in their data schedule for a particular 30-day period and show them the increase in productivity, utilization of operators, throughput, downtime, material flow can all be modeled in these different simulation packages. Okay.
All right, thank you, Dave. Another question we had, what is like the time it would take to implement this sort of project where you include both reality capture and simulation into a digital twin model?
Again, it goes down to the size of the factory that you're trying to build. Um, Laser scanning can take up to 3-4 weeks. Then we have to do the model building, and then they ship that over into our simulation software for depending on what we want to include. Do we want to include material flow? Do you want to include um, every part detail? That can take up to another 24 weeks. So in all, we're looking 6 to 8 months. Um, if you want to start building the model ahead of time to get throughput issues to see what a basic layout would work, you're talking anywhere from 8 to 12 weeks. At the same time, you could be scanning the existing factory and see how it's going to fit once you get done and merge those two together at a later point in time.
Okay, thank you, Dave. And another question we had, what is the benefit of going to PMC for this type of project?
Well, one of the things that PMC does, we not only are the largest laser scanning company in the world, our industrial engineering team has the ability to come in to visit plants. We offer that service. Then we offer the digital manufacturing using the simulation software. We're a low cost solutions provider in that. Our engineering offices in Brazil, Mexico, and India allow us to offer a low cost solution. Laser scanning can be done in the US. Our CAD team in India is very large, and we have quality assurances that no project leaves without being um, validated by one of our US quality engineers. Um,
All right. Thank you, Dave. I don't see any further questions coming in the chat box. So with that, I will close the Q&A session. So thank you for answering those questions, Dave. For a schedule of upcoming topics that PMC is covering, please be sure to go to our website at www.pmcorp.com. Click on the resources tab and scroll down to webinars and events to register for other PMC webinars or check out events that we are going to. As I mentioned before, this webinar is being recorded, so please be sure to visit our YouTube channel, search PMC videos, that's videos with an S and all one word, to view this recording and then to view other potential topics of interest to you and your team. So with that, we'll conclude today's webinar. I'd like to thank everyone for your participation. If you think of any additional questions or would like to discuss how PMC can help you design and implement your own process improvement strategies, please contact us at the address now on your screen. Well, I don't see you have a contact thing button there, Dave. So if you want to shout out your email, if people want to contact you directly.
yeah, it's dstone at pmcorp pmcorp.com.
Okay. And you can also, be sure to reach out to us at marketing@pmcorp.com or info@pmcorp.com if you want to submit an inquiry. Or obviously you can request a quote directly through our website. And you can do that. It'll be at the top right of your screen. But with that, that will close today's webinar. We look forward to working with you or perhaps joining you at another one of our webinars. But I want to say thank you and have a great day, everyone.